Okay. So in this lecture, I'm going to discuss about a very interesting and important topic of DAC interfacing with 8051. The topic is sinusoidal signal generation using DPTR. So how we can uh, generate sinusoidal wave using DPTR, and for that we have to write one assembly language code. So here the objective of this lecture is to write one assembly language program where I'm going to use DPTR to generate a sinusoidal wave. Okay, this is a very common and interesting topic of DAC interfacing with 8051. Now, if I write an equation of a sinusoidal wave, that is, for example, x equal to 5 plus 5 sine theta. Okay, now this signal, if I draw, then this will be looking like this. Okay, so this signal has a minimum value of 0 amplitude of 0, and it has a maximum amplitude of 10 volt. All of you know from this equation. Okay, so this can have a maximum value of -5, minimum value of -5. So +5 -5, it is 0, and it can have a maximum value of this component have a maximum value of +5. So 5 plus 5, it is 10. Okay, so maximum value is 10, minimum value is 0. Now, how this is I have discussed with respect to uh, continuous point of view. Now, how to represent this continuous or analog signal in terms of digital signal? Okay. Now, here what we see that this is the reference, or this you can consider as 5 volt. Now, here the range is from 0 to 10 volt in analog. However, in digital, the same thing range is from 0 to 255 in decimal number system. In hexadecimal, you can have from 00 to FF. Okay, in hexadecimal number system. So for your better understanding purpose, we'll take the range from 0 to 250 decimal number. Okay, now it means 0 volt has to be represented by 0, the 10 volt has to be represented by 255. That should be the range. Okay, now, so what we can do, one entire cycle, if we take, that is for a sine wave or cos wave also, this 360-degree. Okay, it is covering 360-degree. Now, if we take 12 of such samples and the corresponding discrete value, if I save in my lookup table, and if I call each of this value one after another by using DPTR, then easily I can get this sinusoidal signal. Yes or no? Okay. Now, so what I have to do, the total 360-degree, for example, I am doing 12 such discretization, or 12 samples I am taking. So 360 divided by 12, so it is 30-degree interval I need to take. Now, if I take 30-degree interval, then the first angle, what I am supposed to get, that is 0 degree. So for 0 degree theta equal to 0, this signal will become 5 plus 0 sine theta, because if theta equal to 0, then this 5 sine 0 is 0, then ultimately I am getting x equal to 5 volt. So in analog system, x equal to 5 volt means what should be the corresponding digital or decimal value. So we can calculate it very easily. So 10 volt of analog value corresponds to 255 in corresponding digital value or decimal value. Then 1 volt corresponds to 255 by 10. Similarly, 5 volt, in this case I have x equal to 5 when my theta equal to 0. So that is multiplied by 5. So this is round figure because this digital value cannot have a fractional value. So it should have value of 255 by 10. So this 25 into 5 means it is around 127.5 if I'm not mistaken, then it is around 128. Okay, this is around 128. It's 224. Yeah, then 15. Yeah, correct. This is around 120 decimal value. Likewise, if I do the similar kind of thing for the next theta, that is, as I am taking 30-degree interval and I have planned to take 12 such samples from one complete cycle. So after theta, the next value will be 30-degree. So for 30-degree also, I need to do the same calculation. Now put xt equal to 5 plus 5 sine 30-degree. Now calculate this value and find out this thing. So whatever the value it comes, follow the same procedure. 10 volt equal to 255 in decimal, 1 volt equal to 255 by 10. Similarly, x volt equal to this 255 into 10 divided by x and take its round up value. Okay, so that value will come around 176. Okay, I already calculated all these values and I have written here. Okay, so likewise, if you take theta equal to 60-degree, then the analog voltage what you will get, its corresponding digital value in decimal number system, it will be 218 and so on. Okay, so you save all these 12 values. You can use decimal number system also to save these values, and the values are 128, 176, 218 and so on. So these are the 12 values. Okay, now what I'm doing, I am using my lookup table to save all these 12 values. So you know in 8051 the syntax is you have to take any location, that is org 500 I have taken here, then you use db define byte and save all these and write all these 12 values in comma. Okay, now how to write the program? So org 000h, then move a, so initial value of accumulator I am considering as 0. Then move R5 equal to 12. Why I'm taking 12? Because my objective is to take 12 samples. So I'm considering these 12 values as saved in my R5 register. The R5 register is having value of 12 that will be used as a counter, which will be decrementing in every iteration. Now move DPTR equal to 500, hashtag 500. Why? Because I saved all these numbers starting from 500 location. So I'm taking the 500 value in DPTR. Now the next instruction is move C A comma at the rate A plus DPTR. So whatever DPTR is indicating, that location I need to access here. As my initial value of accumulator is 0, it is not going to create any problem. 0 plus DPTR only I'm adding, and the address is 500. So it means at the rate of 500, what data I am having, that I need to take. So in 500 location, the data is 128. So that will be coming in accumulator, and that I need to show in P2 port. So in this program, my objective is to show each of this value in P2 port so that I can display this sinusoidal wave in P2 port of 8051. Okay, I want to display this sinusoidal wave in P2 port of 8051. That's why I have moved this value of accumulator, current value of accumulator to P2. Now what I need to do, I have to now access the next value. So for that, I have to increment the value of DPTR so that it can come to 501 location, next address. So incrementation of DPTR, but as you are going to use move C a comma at the rate A plus DPTR next time also. So something you have to do to take care of this accumulator so that it cannot create any problem to access the data through DPTR. I need to somehow make this value 0. So what I am doing, move A comma 0 0. So I am making the value of accumulator 0 so that it don't create any problem. So after that, what I have to do? Decrement jump no 0 R5. So I am doing the decrementation operation of R5 because I have already taken one value. I need to take the next value, and I have to iterate these things. I have to jump to here until my R5 value becomes 0. Okay. So it means in every iteration, I am decrementing the content of R5, and I need to iterate these same steps until my R5 becomes 0 because I need to access each of these values. This is the objective of this program. Okay. So if you have accessed all these 12 values, then what you need to do? So you have completed one complete cycle. Then you need to repeat the same process for the next cycle. So what you need to do? Short jump back, sorry. So you have to use short jump back to come over here, and then you have to start the process once again so that you can continuously get the sinusoidal wave. Okay. So hopefully all of you have understood this lecture. Thank you.